Work with another way to graph and deal with functions, polar coordinates. In this, instead of x and y, or instead of x, y, and t, we have a whole new system, r, that uses r and theta. So keep in mind that with polar coordinates, if you ever forget the formulas that convert between the two, you can always just make a right triangle. This would be x, y, and r. And if you put theta as the angle, then you can just use the definition of sine, cosine, and tangent to come up with formulas that involve x and y and r and theta. So with this one, find out when is dr d theta equals 0. So I'm going to begin by looking at the graph. So change the mode and change it into polar form. So r is equal to, we have sine of 2 theta. The theta, since this is a trig function, should probably go from 0 to 2 pi. Although in this case, because this is a double angle, I have a feeling 0 to pi would be enough to graph the whole thing. Let's see. And then with it being sine, the biggest it can get is between -1 and 1, where it's min and max, so that should graph it. It makes what's called a 4-petaled rose. So when is the derivative equal to 0? Well, usually we think of the derivative equal to 0 at a place like this, where there's a horizontal tangent line. But that's talking about slope, and slope is made from dy dx, or delta y over delta x. This is not talking about slope. This is saying the r is changing every time the theta changes. So as this thing is graphing this petal, let's say I didn't really pay attention to the direction, but let's say it went this direction. So that means at this point right here, when it gets to this point, then you could find that point by saying there's an r value, which is going to be the length, and there's a theta, which is going to be this angle right here, which I drew to be about 45 degrees. So then you let the theta get bigger, or change the theta, and it's going to say, okay, then go to here. So as the theta went from this small angle to the bigger angle, the r just got bigger. So this question is then saying, when is this growth rate going to equal 0? So as the r gets from here to bigger, it's doing it at some speed with respect to theta. When is that speed equal to 0? That's what this question is asking. So let's take the derivative, dr d theta. The derivative of sine is cosine of 2 theta, and then times 2. So it's just asking when is that equal to 0. So if you look at the cosine graph from 0 to 2 pi, with pi in the middle, then there's going to be right here and right here. So 2 answers. One would be pi over 2. This one would be 3 pi over 2. And then it's going to be 2 theta equals that. Because it's 2 theta, that means we should be looking for twice as many answers as usual. So that means we should actually follow this graph out for another cycle. And get 2 more answers, so right here and right here. So we would have 2 theta can equal pi over 2. 2 theta can equal 3 pi over 2. 2 theta, the next one right here would be 5 pi over 2. And then 2 theta is, this last one would be 7 pi over 2. Then divide all of those by 2, so we would have theta is pi over 4, at which point I should check and make sure that this makes sense. So if you trace and go to pi over 4, Does the derivative equal 0 there? So this is when it got the farthest away from the origin. So in other words, it was going from here to here is the r, then from here to here, the r is getting bigger, and then right here, the r gets the biggest. Or in other words, when you take the derivative and set it equals 0, you're finding where there's a maximum, or a minimum, in this case a maximum. And it's the maximum of this thing, of r. So then, after this, it's going to go from here to here, which is smaller r, and then from here to here. So the derivative would be positive here because it's getting bigger, and then derivative would be negative as it's coming back because it's shrinking. This would be where there's the maximum r, which is going to be, you'd have to do the Pythagorean theorem with 0.707 and 0.707 to find out what that actual r is. So then we would have all of those thetas, and so next 3 pi divided by 4, that should be either here or here or here. My goodness, what's that about? Oh, I forgot to put divided. 3 pi divided by 4. Okay, that's a keeper. And 5 pi divided by 4 is over on this one, so this should be 7 pi over 4. Excellent. So then 3 pi over 4, 7 pi over 4, and oops, this one is 5 pi over 4, and then 7 pi over 4. So there is the answer to this question. Where is the dr d theta equal to 0? Or when is it equal to 0? At these values of theta. Next, find the slope of the tangent line at the pole. Well, let's see. Slope of the tangent line, this goes back to Math 3a. This is saying dy dx, which is not the same as dr d theta. So dy dx means, well, we need to know what x is equal to and what y is equal to. And you can use these over here, or just remember what is x equal to. Let's see, so if I use this side and this side, that's going to be cosine of theta equals x over r. So that means x is equal to r times cosine of theta. And for my particular function, r is equal to this. So in other words, x is equal to sine of 2 theta times cosine of theta. All right, what about y? So go back over here. If you use this for y and r, so that's going to be sine. So sine of theta is equal to y over r. Or in other words, y is equal to r sine of theta. Usually you end up just remembering these formulas. X is equal to r cosine of theta, y is equal to r sine of theta, because you're going to use them over and over again, especially in Math 3C. So this one, replace r with what we have for our particular function. So these are general formulas. Then you apply your particular information that here r is equal to sine of 2 theta. Now we have x as a function of theta and y as a function of theta. So we would then be able to find dy d theta, take the derivative, use the product rule. We'd also be able to find dx d theta. And then if you divide those, what's going to happen is the d thetas are going to be canceled and you're left with dy dx. So that's how you find the slope of a tangent line when you're dealing with polar functions. So let's go ahead and take the derivatives here. So dx d theta is going to be the derivative of sine is cosine, and we need the chain rule, so it's going to be 2 cosine of 2 theta, and then this cosine is left alone. And then we would need to go plus, leave the sine of 2 theta alone, and the derivative of cosine is negative sine. And then for the derivative of y with respect to theta, the derivative here, again, is derivative of sine is cosine, and you need to take the derivative of the inside, so 2 cosine of 2 theta with the sine left alone, and then plus, leave sine of 2 theta alone, and then the derivative of this sine is cosine. Alright, so we've got our derivatives. We just need to divide them and then figure out what this is talking about at the pole. The pole is in polar form, talking about the origin. So when is it at the origin? Perhaps it's when it started at 0. Yep, there we go. And then it goes out and it's going to hit it again. Goes out, hit it again. So let's find this one. So when theta equals 0. So we would then have dy over dx. So dy over dx is going to equal, so this we're going to use zeros. So 2 cosine of 0 times sine of 0 plus, now use 0, so sine of 0 cosine of 0, then dx. So this one is going to be 2 cosine 0, because it's 2 times 0, and then cosine of 0, and then it's actually minus sine of 0 and negative sine of 0. Oops, this is a 0. Wow. Let's see. Sine of 0 is 0. So anything that has sine of 0, this is gone, this is gone, this is gone. So that means we've got 0 on the top, but do we also have 0 on the bottom? If so, it's undefined. Let's see. Cosine of 0 is 1 times a 1 times a 2. So it's 0 over 2, or in other words, the slope is equal to 0. I know this was a long problem, but let's just check real fast. If you go to second calculate, it can find dy dx. So dy dx at the origin, the answer is supposed to be 0.